Hello world. I'm trying out a new camera setup today using my iPhone. So let's see if this works better. Checking out the 30-day LeetCoding challenge. We're on day 9. Let's see what the problem is today. We're on min stack. Let's see what this is. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Okay. Push, that method pushes an element X, so the argument, it pushes it onto the stack. Pop removes the element from the top of the stack. Top retrieves the top element, so just returns whatever the top element is. And get min is kind of our special method here, the one we need to do in constant time. It retrieves the minimum element from the stack, no matter where it is in the stack. So let me just kind of formulate my thoughts on like a stack itself, the concept. A stack is a data structure where, I guess, let me find something I can show this with. Okay, I'm actually in my kitchen right now, so this is perfect. Got these 2 notebooks and this jar of peanut butter. High tech, right? Okay, so we could call this a stack in that there's layers of elements. So we have a notebook, we have a journal, then we have a jar of peanut butter. So if I'm gonna remove something from the stack, I need to pull from the top first, not from the bottom. So a stack is basically this motion. If we have an empty array here, we start by placing an element on top of it, and the next element we add is right there, and then we get to that point. That's as simple as I can make it. So, the stack itself, we're going to need an array, of course, to store our data. So array, property, well, really, property which stores an array, and then we need our methods on the stack, which are push, pop, top, and get min. DS, obviously, stack slash array. And let's check out the examples. We have, we've got, oh, this is a little straight, okay. We have min stack, which we're using a constructor function to make it. So we will assign the properties right inside of this function. The state in there. And then, as you can see here, down in the JavaScript implementation, we have our constructor function min stack. We know that because this is capitalized. That's the constructor function, I guess, convention. Just capitalize the first letter of it. It's pretty unwieldy in that it relies on you remembering to do that. So that's why I prefer Olu for object creation. But after that, we have min stack.prototype. This is where we're kind of we're making class methods, if you want to think about this classical inheritance. And then we're adding a property push, which is a function. And then here we're going to push element onto the stack property, whatever that's called. Then we have pop, remove the top element from the stack store. Top is return top element from the stack store. And get min is return the smallest integer from stack. Do we know it's an integer? We don't know it's an integer. So that's something, if I was in an interview, I'd ask to make sure. How do we know what element is smallest? What are we comparing them with? So algorithm, I need to initialize state on min stack. So this initialize property named store on min stack constructor. Then push is just, we're just going to use the array push method. Use push method built in. Pop, use pop method built in. Top, we're going to return the element at store.length -1, because that's the element at the top, it's the last one. And then get min. We basically need a way to store the min element as a property, so then we can take advantage of constant time lookup to get that minimum element. So we need to be storing the minimum element as we push and pop elements from the array as we go through it. So we could do that. Let's see. This also doesn't say if there's going to be duplicates, which that might get in the way. Get min. So basically you want to store a minimum element property on min stack. And so each push we check to make sure the new element is larger than min. If smaller than min, reassign property to point at new min. Now, each pop, we check to each pop we need to check to make sure that the current element isn't the minimum element. So I'm not sure what time complexity they want here. We could do this pretty fast, but I'm going to focus on doing this in linear time with math.min. Each pop, we must ensure the min element gets reassigned if the min was popped. So each time there's a pop, we call math.min with the store. Let me see how we use that actually. Can't remember. Okay, pass it as this arg. Okay, we use the rest parameters here. And then for get min, just return the property min from this. Top, return the, oh, already that one. Okay, so this seems all right. We're gonna start it off with this.min equals undefined, and this dot store equals an array. Now here, we're gonna do this store push x if this dot min is less than x. We want to reassign it. This dot min is equal to x. Return. Here I want to do this dot store dot pop, and then this dot min is equal to math dot min store return. And we're going to return this top element. This dot min is equal to undefined. And then here, we're just going to return this dot min. So let's see down here, we have some extra notes about how it's going to be implemented. You can see here that for top and get min, we want to actually return the element. So we have that here. We can actually do that. Push, we don't know if it needs to return the popped or pushed element. Let's just run it and see if there's any obvious problems. Okay. We're missing a -3. So our commands here are we initialize the min stack, we push -2 on it, and we push 0, and then we push -3. And then get min should be returning this dot min. Okay, so the problem I had was that I said this dot min should be less than x to reassign it, whereas we want this dot min to be greater than the new element we're pushing on. Yeah, let's just run that again. Let's see if we submit it. What do we get? Okay, that worked. I didn't know if the time complexity would be good enough, but it was. 94%. Pretty good. Thanks for watching. Have a great day.